I'm trying to make a computer in Minecraft. I can say that, but I actually have very minimal knowledge about redstone in Minecraft and have only ever done basic doors, traps, and farms I had seen online. However, by trade, I am a computer engineer, and I had seen the parallels between what I do in real life versus the logic behind Minecraft redstone. So I thought, why not use my knowledge in real life and combine it from my love for Minecraft to create something amazing? For the next couple days, I'll be trying to make a fully functional computer from scratch with nothing but computer engineering textbooks and some redstone dust. This is my documentation of that process, and I hope along the way you'll learn something by watching. A computer at its most stripped down state is a bunch of ones and zeros. People always say that, but most get lost along the way on how we take those numbers and arrive at an end product of a fully functional computer. We can represent these ones and zeros using redstone lamps and toggling them with a redstone torch, or any other redstone source. A redstone torch basically functions as the equivalent of an all-powerful battery, with no limits on electronics it can power, except with the restriction that it must be powered within 15 blocks from the source. This simple concept of using powered bits as a representation of a 1 and unpowered bits as the equivalent for a 0 leads us to our next concept: logic gates. The easiest logic gate to understand is the NOT gate, which takes an input and its resultant output is the opposite. For example, if an 1 is ran into the NOT gate, the resultant output would be a 0. We can create a couple more gates, such as the AND gate, which takes two inputs and only outputs when both are on, hence the and the OR gate, which takes two inputs and outputs as long as one of the sides are on, or both. These gates can be chained together to create new logic circuits, such as the NOT AND gate, or NAND gate, and the NOT OR gate, or the NOR gate. Both gates can be made by adding a NOT gate after the output of their respective gates. In this case, it would mean replacing a redstone torch with nothing, or adding a redstone torch to the end. In computer engineering, the NAND gate is considered to be the holy grail of all gates, with its ability to create any gate using only itself. This idea is known as functional completeness, as NAND gates can create every other gate's output using only its own self. In today's world, most of this hardware design is not done physically, but instead with software using hardware description languages such as VHDL and Verilog. These are used to basically run a simulation of the hardware, and then it can be modeled into a chip's memory after. That's not too important for the redstone side of things, but knowing how it works in the real world might also help you understand how it's going to work in Minecraft. There's one more set of logic gates that can be very important for trying to build this computer: the multiplexer and the demultiplexer. The multiplexer can be created using a combination of a NOT, two AND gates, and an OR gate, with its primary use to be serializing multiple inputs over a single output. By knowing what bit selector is on and the output of the multiplexer, we can use a demultiplexer to deserialize the signal and recover whatever data was sent. Seems simple, right? So let's see how it looks in Minecraft. Well, we have S, A, and B on the left, and we have a truth table on the right, which is showing us what the output should be with the different inputs. I'll be toggling between these different inputs, and we'll see that depending on what the selector bit is set to, we're going to have the output of the corresponding value. So whenever selector is set to 0, it's always going to output the B value only if it's on, and when the selector is set to 1, it's going to output the A value. This is known as serialization, where we're taking the A and B value and instead just transmitting it on one data line instead of using two, which can be really useful for compacting, especially in Minecraft. Next, we can make a demultiplexer on the other side using two NOT gates and two AND gates. And by taking the selector output and the output of the multiplexer, we can deserialize the output of the multiplexer and recover whatever data was on the other side. For now, this will be where I wrap up the video, as there was already a lot of information covered in just these short 5 minutes. I encourage you to try making some of these gates yourself, and in the next video, I'll show you more of my process and how we can combine these gates to make even more complex circuits. If you have any redstone tips which may help me out, please leave a comment below, and thank you for watching and look forward to part 2.